Welcome to another episode on my YouTube channel. Tarlan, nice to have you on the show. What are we going to talk about today?
Honored to be here today, Johannes. Thanks for the invite. And we will be diving into the most interesting thing that we have in the modern technical day. Basically, it's going to be around the agentic workflows, about GenAI, about platforms that make that happen as a production workload. And this is the thing that I've been investing my last year totally, even despite my professional career path, which is a DevOps and SRE. This is the most intriguing thing so far that I've been involved with, and I want to share some of that practices and experience with you today by using your awesome channel.
Thank you for jumping on, Tarlan. It's going to be exciting, and we are going to talk a lot about AWS as well, as most of my listeners or viewers know. I'm a little bit focused and biased towards AWS. So we're going to talk about Bedrock, about AgentCore, about the different building blocks that AWS has to offer. But before we go there, Tarlan, where are you dialing in from today?
Azerbaijan, Baku. This is somewhere between Europe and Asia. This is the most hotspot. For the connections, this is one of the best spots to live in. So this is Azerbaijan, Baku, and I'm actually a founder of the user group Baku, and also community builder and so on and so forth. So I'm very involved with the community in here. AWS community. I'm one of the Kickstarters, and I'm honored to be one.
And that's how I also kind of found you. Like, the AWS community is small, but it's still big, right? And I saw you posting an article about a topic that I find very intriguing at the moment. You already teased that in the starting of the session. We're going to talk about AgentCore a lot. But before we do that, what do you do in your day-to-day life and job? I would guess you have a real profession besides the community work that you do?
Yes, exactly. So I work at a company which is a premier AWS partner, and we're helping the organizations and companies to accelerate their cloud journey in AWS and other cloud platforms, but mainly focused on AWS. This is a DevOps-centric company and AI-centric company, and so my overall day-to-day life is all about cloud, which is awesome because I love working with cloud. I love my past, literally. And aside from them, I'm dad of two. So whatever I get, whatever free windows I get, it's dedicated to family and stuff like that.
That's cool. That's similar here. Yeah, that's similar here, right?
Yeah.
And besides all of the AWS community stuff, you also already mentioned you're running a user group. You're also a community builder. I saw that you're also a little bit into the CNCF, doing some stuff over there as well.
Yes.
I want to talk a bit about that.
So my overall journey as a DevOps began with enthusiasm for containers, and everyone knows Kubernetes. I love Kubernetes. My whole journey as a DevOps began mostly with Kubernetes because all the things around the automation and scaling was like booming up with the Kubernetes. Like, we had Docker Swarm and other stuff as well during the time, but all the things come together with Kubernetes. So I've been, fetching all the certificates that I get from CNCF along the way, and also, I'm one of the persistent attendees of KubeCons. I love CNCF events, and that's the most prominent one. So that's basically, I'm kind of a person that is involved with containers, that is involved with cloud, and is involved with GenAI, and the mixture.
And that's I think, a very cool thing and a cool mix in this time of the industry, right? I think a lot of the workloads that we see are not going to be only AWS anymore. Maybe they're going to be shifting between different cloud providers, and that's where the Kubernetes aspect might also become very important. Now, those that listen to the channel a few times, they know that Johannes doesn't love Kubernetes, but still I do it, right? So I think we have a common ground here as well.
Yes.
But today we're diving back into the AWS portion. Like the last videos, the few videos that we had on the channel were mainly platform engineering focused. Now we're gonna look a little bit back into the AWS world. So tell us a bit. What is the kind of storyline of what we are going to talk about today?
Yeah, sure. So the very core point of the whole conversation is going to be around how things change today in terms of the kind of a Gen AI existing and how it's changing everything, literally. And from an engineer perspective, we have a muscle memory of building and deploying standard applications, right, for years. And this is something new. And this is something new. This is why it should be treated a little bit different. This is why we have new platforms. This is why we have this maturity problem of all the solution coming up. And our talk is going to be around what would be the best way to deliver and to build the life cycle of these workloads based on what we have today, because everything's going to change tomorrow.
And the workloads that you're talking about are mainly agentic workloads and agent-driven workloads, right?
Exactly.
So I think in the world of agentic AI, in the world of running autonomous or close to autonomous agents, it becomes more and more important that we find the right patterns to actually host those agents. One of the last videos on the channel was focused on GenKit, which is a framework of actually developing and implementing agents. Today we are back into the infrastructure world, right? So which are the services that we're going to talk about today, Tarlan?
Today the main focus will be around AgentCore and the differentiation between why it is important versus the VMs, containers, ECS, Kubernetes, Lambda, serverless, step functions, whatever, why this is specific and how to treat it, how to deal with it, how to deal with the automations around it.
Let's start with that. I don't get it. Yeah. Why can I not use Lambda, and why can I not just use my Fargate task to run my agents?
So, with a quick context, I would say, let's imagine that we already had those, right? We already had those serverless, we had containers, whatever. But this bit is a new bit, and this is different because it's, let's say, non-deterministic workflows. We don't know the load. I don't remember of an actual production grade agentic workflow that's been working perfectly on the production side so far based on the containers, whatever, because no one is able to calculate the scale of the application and what is going to be needed and how it is going to mature over time, right? Because as we said, the infrastructure is evolving as we're talking, and the new practices are evolving as we're talking. So we need something new, persistent, and which doesn't change. So this is what AWS provides us with AgentCore. And AWS itself has been going through this paradigm of changes. We have the Bedrock agents, we have Bedrock platform, and now we have Bedrock AgentCore. We had a lot of other services as well. But we need to stop and to get a momentum to build up throughout something consistent. And this is what AgentCore provides. It provides a standard platform. It provides you exactly what you need for an agent platform. With all the tools standardized for you to have under your hand, so you can build your application and focus on the code base.
Okay, I think I understand that portion. Now, it feels like re-implementing some of the building blocks that we also had before, at least a little bit, if I look at it from the outside, right?
Yes.
And I attended one of the talks around AgentCore at reInvent 2025, and a bunch of the concepts under the hood are also being kind of reused, right? Like isolation for the different components of the AgentCore runtime and stuff like that, right?
Yeah.
Same, but on the same privileges as the Lambda virtual machine isolation, right? Firecracker, and I think there's a lot of similarities between the existing platforms that we have and AgentCore now extending that by more default patterns on how to build agents. And I think that's what the core around is, right?
So that's the exact strawberry over the cake. So as I said, we need more consistency, because if you'll just stop for a second and think of what you're going to build tomorrow, the thing that you're building is going to be obsolete because of just some new awesome thing was created. Like imagine the function callings, the tool chaining, whatever. Then we had MCPs, then we had this, and then we had platforms. People have been building on Lambdas, serverless architectures, and it works perfectly fine. I've been doing that, but I don't want to think of that it's going to be a not good way of dealing with agentic workflows at some point, and I will have to shift back, because if you're sticking to serverless, it has to be designed in a specific way. And if you're sticking to something different for the containers, the whole architecture, the whole solution is going to change, and you have to adapt to it overall. And that's a huge pain point. So what AgentCore does, it tries at least effectively so far to eliminate that change and to give you some consistency so you can focus on your agentic workflow and the functionalities over it. So I believe that's the core, and that's the strawberry, as you mentioned.
Yeah, cool. Let's look a little bit deeper. If you look at the different services, and I think we're going to cover different components of AgentCore, we're going to cover runtime, gateway, memory, and identity today. At least they're going to be part of the architecture that we look at.
Yep.
And obviously the IAM, like the policy component, is a big one. What's your favorite one out of those? What's the most important
Memory,
one when building
100%.
Memory, okay, would have been my choice as well. So let's dive into it, and let's look into the article that you wrote and talk about the details of the architecture that you're proposing.
Yeah, let me share my screen in a second. I'll be grabbing the right. Here we go.
Let's go.
So here, this is a Dev2 article. I believe we will be sharing it in the description or somewhere. But this overall talks about whatever we just said. And this is about AgentCore, how we can use Terraform in order to automate end-to-end everything.
Wait. You're an AWS guy and you're using Terraform. Why the hell?
Because I love all the fancy things that is provided by CloudFormation stacks. I even use Terraform on top of CloudFormation and CloudFormation stack sets and whenever it's needed. And it's a very perfect use case to sandwich that infrastructure as code. But Terraform is, I would say everything began with a Terraform and it will end with a Terraform, no matter how many people say that Terraform is dead, switch to something new. Because this is the most awesome way to declaratively define your infrastructure. It's been this way, it will remain this way for long, even after the boom of the GenAI, for long time. Because it is cloud agnostic. We can deal with everything using Terraform. You can build your own plugins using Terraform. And you can control everything. You can mix things up. You can. It's not always good to mix things up and make them more elaborate. But I mean, that there is no problem that you can solve infrastructure-wise. Like there is no such problem that you cannot solve with Terraform if it's infrastructure-wise. And we will be diving into that as well within the code base, basically.
Then let's not fight about that and let's keep going.
Yeah. Okay. So I wanna just have a focus on the architecture part. So this is the overall solution, and to talk about the solution itself, I called it Bootstrapper
Tarlan,
AI.
The picture is opening on a different screen. That means if you kind of enlarge it, maybe that would be...
Sure.
Yes, sure. There. Thank you.
Awesome. So here is the solution itself on the high level, how it looks like infrastructure-wise. And I called it Bootstrapper AI, and this article talks about the Agent Core and its components and how to automate the stuff. And the main subject here is this. I just needed a demo, right? And I just implemented this thing. And it's very fancy. I don't think that it has a huge value versus whatever we have today, like cloud code, automations, whatever agent. There are a lot of ways to, just ask an agent to build an infrastructure for you, or build its Terraform code for you, whatever. But this is one of the best approaches because you have the CC API MCP server here, which is also deployed as an AgentCore runtime. And you're using the supervisor in order to interact with the NCP. MCP has access to your infrastructure, and you are literally giving the prompts and getting the infrastructure and infrastructure code and provisioning, deletion, whatever. You can control your sandbox account by using it, and you won't be needing to have kind of authorization issue like from an external source into AWS. It is already deployed within the cloud, right? It can go and look up its own logs just to find the problem related to itself. Like you can do a lot of interesting things with that. This is the fancy thing about this solution versus the other standardized ways how to deal with it. So it's called Bootstrap AI. It has two MCPs. One of them is Cost Explorer, just to have variety. Another MCP just would give you a analysis of the cost, how they may occur. And the other one is just the CC API implementation, which is almost the same thing used by CloudFormation, the same principles. Okay. So you can just by using natural language provision infrastructure and get the infrastructure code of it, and let's say push it to GitHub or someone and store it, whatever. So and it has all. I tried to implement all of the possible, all of the components, whatever you can reach in Agent Core concept, and the main one is memory layer. And as you can see here, why it is like my favorite one, because memory thing is not that easy to deal with. Like whenever you build an
What
agent,
does it do?
It literally grabs the chunk related to the memory implementation that you would do, in a standard way, and passes it to AWS. Okay, passes it to Agent Core. So you literally configure the memory stack for yourself. You don't have to provision a database, let's say a Dynamo and session IDs and whatever that you want to store it and you want to pass it from your application back and forth. You just do a small configuration. It can be small or bigger depending on your needs, but literally the short-term and long-term memory is just about few lines of Terraform.
So that means that Agent Core memory deals with handling the chat history of a user and also the context of a user and the questions and whatever has been interacting with the agent, right?
Yes.
And this helps us. This also helps the agent to take that into account when coming up again or responding to the next request, right? So I think for those that are not as familiar as you are in building agents, I think that's an important aspect of it, right? Usually the agent session is someone talks to an agent through an MCP server or whatever, and that agent gets information. Now, after that agent finishes his work, the context is kind of directly lost, right? And Agent Core memory makes that simpler to actually keep that context throughout various sessions or throughout multiple weeks or months, right? Can I configure the length of the memory somehow?
Exactly. You can configure the long-term memory kind of a configuration. You can say that after 7 days, once we had this chat, summarize it based on the methodology that you want to use it, or you can customize the way you want to store your long-term memory. But I can dive onto it in the code base once we deal with this introduction part. I can show you just simply how like stupid simple it is just to configure bootstrap the very basic memory that you would need. Like let's say you're using Slack as a client, and you have some agent in the background like AgentCore, and you just want to store thread-based memory or chat-based memory. It's just all about just passing a session ID and it will be dealt for you. From that point on, it's going to be an AWS part, infrastructure problem, not a code problem, not even an instruction problem. It's going to be a platform problem, okay? And it's dealt perfectly fine. Like whatever it promises to bring to you, whatever value it's promised, it's going to bring to you once you use it. And once you taste it, it's addictive because you don't want to go back and manage it all by yourself because it's very tricky. So here is the overall, as I said, the architecture of a such solution. There are some caveats related to the policy thing. There are a lot of ways to go here. So the main way that you can go is whenever you implement an MCP, you can directly use it. Like if you use Stans SDK, for instance, it's just going to be another tool that you implement in a few lines, and you're going to be interacting with an MCP through the Stans directly. In that case, you have to go totally different. But if you want to use the platform itself, you should be using the gateway, okay? And gateway is literally, as its name refers, it's a gateway. It's the standard entry point where you can add tools on top of your agent by using it. And the tricky part is about the permissions to be provided through gateway if you implement it with the gateway way. And I love I love to do it over the gateway because as we said, we want to standardize things, right? If you're avoiding the usage of a gateway, you're not benefited it from for your future,
you're not preparing for growth later, right?
Exactly. Exactly. So you have to go through the gateway in that point.
Okay.
And the tricky point is that you have to provide access to the gateway, and then you have to authorize your runtimes against the gateway. And for one, you use the standard IAM roles, literally, for the gateway. And the other part is M2M, like machine-to-machine authentication. And for that, we should be using Cognito, of course, if you are on the AWS ecosystem already. That part can be a little bit tricky, but once you get the hands of it, it will make all the sense. So you create the user pool, you do the M2M authentication, machine-to-machine authentication just against the gateway to identify the supervisor, which is the orchestrator agent itself, against the gateway, and then you have access to the MCP, and then you have the access to the basically all the toolset that is provided by the MCP. Now, so what to add about the permissions, right? Because security comes first, always. This agent should have almost administrative policy attached to it, because if you have this kind of agent, you want to be able to provision everything, right? Like Lambdas, SQSs, S3 buckets, list them, delete them, create them, whatever. This is why it has to be a sandbox account, personally. But you would like to put something between these permissions and the actual infrastructure, right? And here comes the AgentCore policy. Okay. It's not reflected here because it's literally a policy and policy enforcement. But I believe you've heard of the CEDAR policy concepts, that you write your policies in AWS for more granular patterns, and this is something provided by AWS. So in AgentCore, by using the CEDAR policies, which is a human readable, literally lines, you can put another layer of security between your agent, your infrastructure, or the MCPs, or whatever you want to implement, you want to add as a tool. And in there, you can, on top of the IAM policy, you can define what this tool can build, do, or not do, literally. And this is also implemented within the code base of this project. And potentially we will be playing with it a little bit as we go.
Cool. Okay, so that's the architecture that we're looking at, and it's just a sample architecture at the end, right? So you can extend that.
Exactly.
What would be the first extension point over here? Would it be adding additional MCP servers, or would it be adding additional functionalities of the agent? What do you think?
I think so far I don't have implemented a client for this. I have implemented clients for another like a solutions in production that are actually working, but in this one I just have a CLI. So additional thing might be exploring the gateway just to see what else can be done over the gateway from the potentially for the client side. Just exploring from so everything that you're seeing here is very custom. Like my MCPs are custom runtimes that I'm grabbing. Actually, there is a predefined MCPs. I'm not building them from scratch, but I'm deploying them into the account as a runtime, right? So we could look into what else can be added over the gateway, that is not customized, like built in ways of adding stuff. You can add your functions here. You can do A to A, which is also very nice. If you're doing multi-agent workflows, if you want to build multi-agent workflows, like you can create the main agent runtime would be the supervisor, and you would have some collaborators. And another best thing to add here is a knowledge base as a RAG solution, right? I could extend this workflow by adding a knowledge base and implementing the RAG patterns. That would be awesome. That would be another level.
Cool. So a lot of ideas on how to extend this very quickly. But before we can extend it, we first need to understand it. So let's dive into the details of maybe directly jump into the code and explain a little bit how to start, right? If you want to look at this. And I think this is an open source project as well.
Yeah, I've made it public, literally. Yeah, I've made it public. Can you confirm you see my screen?
Yes.
Okay, so this is the part that I love to show. What I can just drag your attention to here is mainly we have Terraform folder, we have MCP servers and application stack here. So you consider a scripts folder, whatever. I'm gonna explain why they exist in one repo. So as you know, we have a lot of ways of defining infrastructure for AWS. So far, we are very used to AWS CLI, just to imperatively define configurations or just fetch something very fast. Like it's very convenient, it's awesome. And with AWS CLI v3, we have even support for the AgentCore based resources. Okay, and I have all the updated versions and so on and so forth. So for the applications before the time, like let's talk about, let's say EKS or ECS, whatever. everything is muscle memory, right? We have GitOps, we have some task definitions for ECS, how we implement the CI/CD, we fetch task definition, we change something there. So that all those things are already invented, battle tested throughout the years. So I'm battling something new now, is how I'm gonna deploy the whole application. Because if I'm gonna use the AWS CLI just for deploying things, it's gonna be very complicated because
True.
I won't be able to capture the state. I have to write something down or automate it by using bash scripts as we used to do like 10 years ago, right? This is not a good way to go, especially in this era of the agentic AI, of general AI. So we need something fancy, and this is how I came up with the solution. It's already reflected in the blog as well. So we have a monorepo here. It can be not a monorepo or decoupled repo, for which I will show you another use case. But the overall idea is that if our workload, agentic workload, is now 50%, I'm just throwing numbers, 50% platform, 50% code base, and I want to deploy it, there is a huge chance that I will be changing the configurations rather than changing the code at some point, and maybe the mixture of it, and maybe I'll be changing the application only. But it will be very tricky to go back and forth and apply Terraform and go back and adapt it on the code side, whatever, and deploy it and automate it overall. So this is why I think the monorepo for AgentCore is the ideal scenario, because now I can build everything in just one repo and automate it from one, entry point. So this is the Terraform. As you can see, there are Terraform code base here, declaratively defined. I have the MCP service defined here. I have the application code base defined here. Now we have to wire it up, okay? Now we have to wire it up to come with the monorepo. And as of today, we have the Terraform provider, Terraform AWS provider, which covers AgentCore resources. But there are some gaps. As I said, as this is something that is maturing as we're talking, it's a very, very early stage. We have some missing points. So one of the gaps is, for instance, I talked about the CEDAR policies, but there is no way of defining those policies by using the Terraform, okay?
Yeah.
Like, there is no such way to do them because there is no such resource defined. You can go and open source, use the open source and maybe contribute to the community by creating your own, pull request. But as of now, we don't have it. We have, let's say, the 60% of what we need, but the rest has to be figured out. So we are closing that gap by using the AWS CLI or Starter Toolkit, which is another CLI tool. Okay, it's kind of a hybrid. Like, we are putting the scripts into the Terraform so they could have state. I know it sounds a little bit ridiculous, but this is how it works. I believe our listeners, they're more like a cloud, like if they're interested in DevOps and stuff like that, they have heard of a tool called Ansible, for instance. So idempotently running things alongside with the Terraform, just for the provisions. You can even utilize Ansible for running scripts just to have more idempotency, but it is unnecessary. Here, I'm going to show you how we can put those missing gaps. One of them is CEDAR policies, another is them gateway targets, okay, into the Terraform as well by using simply the bash scripts, okay. So let's just look into the policies here. So this is the thing that I've referenced already multiple times. This is the CEDAR policy. AWS provided a way of defining granular policies for multiple things. One of them is AgentCore policy, okay. And here I have that security layer that I've been talking about, that what my agent can actually create. As you can see, I have the resource type here defined, which tools can be called against which resources, you see. And it's a deletion, like CRUD, basically create, read, delete, and update thing. And I'm defining granularly what my agent can do alongside with this administrative policy, okay? This is another security layer. So here we have the CEDAR policy, but there is no Terraform resource. So what I'm doing currently is simply defining a null resource and using the provisioner, okay, on my local machine. So my local machine is going to utilize a bash script called setup policy. Okay. And if you look into the setup policy here, this is just elaborated bash script, but at the end of the day, it's just using AWS CLI.
Yeah, okay.
Yeah, exactly. So this is how we are closing gaps
So that
in
means
this
that
scenario.
but that's the usual pattern on the Terraform side of things, right? Then it obviously means that you need the CLI, the AWS CLI installed wherever you execute your Terraform script, right? But other than that, it would work.
Yeah, exactly. So we're kind of mixturing the imperative and declarative way, and we're making it mostly declarative by adding it to the code base, and we can track it, we can update it, we can know how things happen. At least we're not going to forget about the command or have to write it somewhere else. It's going to be, version. It's going to be as the whole part of the thing. And let me drag your attention to another thing. So imagine that you don't have the monorepo. Okay, you have the standard way of deploying, let's say, AgentCore. How that would happen? You would provision infrastructure, and you would go to your code base and create some pipeline or automate, the whole process, or just manually deploy stuff. What we need to do, whatever we have defined as a configuration on the Terraform or the infrastructure side, has to be passed again while we are creating the new version of the runtime. Okay, what that means? That means all the environment variables that you can see right now here, like environment variables, all the protocol, HTTP, network mode, public, whatever, everything has to exist while we are creating the new version. I don't know how, I believe you are familiar with how you're usually automating ECS deployments, right? There's a task definition. You have to read its active state, then you have to change it, and then you have to deploy the new task version, and you have to edit the service and point to a new task revision. This is very similar, okay? The only caveat is that you don't have AWS support, AWS CLI support for it. So you're building, orchestrating the whole process. You're reading the current runtime, you're fetching the environment variables by using Bash or Python, and you are copy pasting them to a next stage as a JSON, and you are provisioning the whole thing by using the whole information that you gathered by imperatively, which is very nasty, right? It even sounds nasty. So this is why Terraform is the ideal solution versus AWS CLI, or at least the runtime, starter toolkit, in my opinion, because by using this potential this flow, you can deploy the new version effortlessly. And the only thing that you have to do is to re-trigger this whole thing to be deployed again. So in the whole, on the screen, you can see that there is one environment variable here called version. Like this is the workaround, and why we need this. So in Terraform, as you know, if the properties are not changing, there is no need to update the resource, right? We need something to change in order to provision a new kind of either to update it in place or delete and create a new version, right?
Yep.
And if you are building by using the last resort approach, which is Terraform's last resort approach is using provisioners that we are using because there is no other resort to make use of. We are using the last resort by using the local executioner. So we are packaging MCP, or we are packaging the whole application by using the script. We are putting the zip file and putting it to an S3 bucket, right? And then pointing to it from the AgentCore runtime, as we can see here. So agent runtime artifact, here it is, and we go, the code base is in S3, this is the bucket, this is the code, code bucket, and this is the key for the file that we have to deploy as our runtime, right? If nothing has changed in the name, in the ID, in the S3 bucket, there is no way we can re-trigger this whole thing and create a new version. So this is why we are using the hash of the source code as it changes to add a non-used environment variable into the configuration. And it says, oh, I have a change in the environment variable, so I need to redeploy, and I need to go and grab that file again, which is an artifact, and deploy it again. At that point, it is not aware that the actual code base is different. Because its name is the same, it cannot go and check the the blob or whatever in the code base. So this is why I'm using this, and this is the perfect way to deal with it. If you're not using the ECR or containerized version of deploying AgentCore, which is also possible. I just love it this way. I don't know why. I just want to go away from containers maximum as I can in this specific use case.
Of course,
so I'm using the artifacts from the S3 in this case, and the whole automation goes on top of that.
Okay, so makes sense.
As you can see, MCP runtimes here is the part that is dealt for the you can define all the runtime, whatever, and you can build it by using the scripts again to just define the new artifact and pass it through the whole thing. Another gap.
Let's look at first the memory component, because I find this one the most interesting portion, and also the integration of that. And then we're gonna look at policy, and we are already at over 30 minutes. Let's dive into memory, and then we dive into policy.
Okay, so the holy grail of the whole thing, as we said, it's all about 20 lines, as you can see. All about 20 lines, 2 resources is the whole thing that you need versus creating end-to-end memory, session memory based on some database or potentially Redis or DynamoDB. The whole thing here, it's defined in 20 lines. So there are 2 components. One of them is the AgentCore memory itself and the strategy for long-term memory. Okay, so here you have you can say I defined everything max, in a variables as it can be. So we have the memory event expiry days for 7 days. So within the last 7 days are being preserved as short-term memory. Okay, so every time when you interact with your AgentCore using the same session ID, it grabs the whole conversation and passes to the next conversation. So you have this consistency that we mentioned at the earlier. Okay, so this is the first part. This is the short-term one, and then we have the strategy. How we're gonna deal for the afterlife of that 7 days. We don't want just our agent knowing us for the last 7 days, right? We grab those 7 days and we use the summarization. You see the summarization type of how we're gonna deal with long-term memory. So we have another option. We have multiple options for the type here. I'll be grabbing the best let's say documentation ever written for Terraform AWS provider, the latest version. And I'm going to show you just what are the options so that we can understand why I'm choosing the summarization here. Okay, so this is exactly the resource that we are defining in the code base. It's called AgentCore Memory Strategy. And here, I'm going to repeat this one, but I really love Terraform documentations alongside with AWS documentation because it's very short, concise, and just snaps to the point, right? So we are managing the AWS Agent Core memory strategy. We have 3 built-in options, which is semantic, summarization, and user preference. And user preference is something that you can customize, obviously. So we're using this summarization. What it does, it grabs the 7 days of conversation, summarizes, holds it as a summarized short version of what have been discussed for the last 7 days, so that your agent doesn't lose whatever you had previously. It can kind of get a customization of your conversation, and based on the next upcoming query, it can respond to you consistently. So overall, you see there are override options. So this is not that simple as it seems at the very. You can use a built-in version. You can use the go and further and use the type custom, which is another layer. Okay, we can talk more about it, but whoever is involved with the GenAI knows what it's all gonna be about, right? So you can dive into your options here and do more sophisticated memory configurations. In our use case, it's just the summarization for the demo, so we don't go and use the customized versions of it. But overall, you get the idea. Let's just trigger an update, because I just talked about the Terraform, the code base, the Monorepo, right? I can show you how everything comes together in the GitHub, YAML file, which is a GitHub action flow. In this workflow, you can see this is pretty much for the demo purposes, so you can decouple it to multiple workflows. But here I have one big workflow that decides what to do based on the type of the event, which is either pull request or a push, right? And whenever I'm doing a pull request, I'm doing the plan of the Terraform, and whenever I merge it, I go through the apply workflow. You can do it much more better in a GitHub Enterprise or Teams. You have the deployment kind of triggers that you can build more elaborate, more professional, more production ready kind of workflows. But this one is just for the demo purposes, so we are relying on that. This is not a huge team and so on and so forth. So these are pretty much standard GitHub actions we're checking out for, and we have as this is an infrastructure as code and everything is codified, now we can run Trivy, Checo, and other utilities on top of our infrastructure code just to find something that is not matching best practices, our internal regulatory compliance or internal rules, right? We can do whatever we want with it because we know it is it is a code base. And the code base can be treated differently.
Yeah.
And we can do the TF linting, as you can see. And I have some custom workflows here, which comes from AWS Baku organization. It's about adding the findings to the pull request as a commentary. So you can read what is going to be planned, what is not okay, which resources have a security gaps, and so on and so forth. And overall, you can see security scan for the Trivy, and then we do the Terraform plan. So whatever I would do in my machine, I'm doing on the GitHub Actions Runner machine, and I'm just orchestrating the whole thing. So if you look at it, it's pretty much nothing sophisticated. Okay. So the Terraform plan, it is working on the Terraform directory, which is Terraform. We don't want to run it on the root, of course. And here is the overall what happens. Okay, Terraform plan, color for the CLI, and so on and so forth. So we are orchestrating the whole automation at this point. And let me just grab it. Okay. And the very ultimate thing that you would do is just to do the Terraform apply.
Of course,
so
yeah.
Let's just see this whole thing in action. Okay, I already have checked out from main demo branch. So let me just zoom just a little bit so viewers can see what we are doing. We don't need this part as well. We can directly go like this. Okay. So currently I'm in the Terraform folder. So this is the whole, the whole folder, as you can see. And in the Monorepo, I have to go to Terraform as if I'm an, CI workflow. I'm just repeating whatever CI would do. So here we have the Terraform files that I've been showing with you. Here I'm gonna go and one step back and show you how I'm currently triggered. Okay, let's call it demo. So this is just a Python CLI command just to run my AgentCore remotely from the AWS. And potentially, one second, I need to export my profile as well so that I have access to this AgentCore runtime. So we are just triggering the basic.
Of course, yeah, of course.
And we will be interacting with it. And I will be asking it to, let's say, to create a resource, and we will change the CEDAR policy and do it again to see it in action and to see how a change in the CEDAR policy will trigger the whole CI workflow. Okay, so let's say create an SQS queue named demo in EU Central 1. Okay, and here it's just invoked. It will just think of it and come to me with a confirmation prompt that I will be creating this. Are you sure? Let's create it. And it will go through the CEDAR policy. It's not going to be blocked, and it will call the MCP. Then they create a resource tool from the official CC API MCP, and that will be the whole trick. So
in this case, you're now talking back to the agent that is running on AgentCore that you have previously deployed, right?
Exactly.
And that agent is going to now do the creation of the resources for you.
Yeah.
And obviously, it asks you for permissions first.
Yeah.
Now, the CEDAR policies that we have deployed as part of this architecture will now verify that you are actually allowed to do that, right? So that the CC API server is allowed to actually talk to the AWS APIs to create a queue, right? Okay, that makes sense. Cool. Yeah.
Yeah, and the whole beauty of it is that there is no mention of CEDAR policy in my code base. I've never touched it on my code base. This is something that is managed on AWS, and even the funny part is that once you enforce the CEDAR policy, like you cannot create SQS, and agent is kind of confused. This is I'm kind of have permissions. Like this is really the output, and you will say, I cannot create it, and I don't know why. That's the only thing that it's like it cannot understand why it cannot create, because within the code base and the system prompts there is no reference to anything like that, and it works as part of the agent core, and the agent itself is not even aware of what is happening. What I'm gonna do in a second, just wait a second. So just to show you. here you have the output. There's a queue name is demo. So it's created. I just want to confirm to you visually that it actually exists in my account in a second. So let's go to the console very fast and just confirm that SQS is there in a second. Okay, here, this is my personal account, obviously. And I'm going to go to SQS. And you can see these are the predefined, resources that we're actually using. And this is the demo one that we created using the Agent Core. And here we have the tagging, which is fancy.
Yep.
It just
Cool.
leaves a track for the audit, right?
Yeah, of course.
Yeah. And so basically what we did, we just used our agent, and I'm going to quickly trigger an update for the whole repository. So that we see it in action, right? If we do a change to any component, it doesn't matter if it's a code base or if it's a CEDAR policy, it's infrastructure side, the Terraform will find it, if required, it will rebuild the application. If not required, it will update the infrastructure right away. And let's go back. So what's going to be the next step here? Let me show you. I'm going to go to the policies section right here, which is part of the Terraform. Policies, safety CEDAR, and let's drag this a little bit. So let's find the section about, create resources of SQS. I'm going to remove this. I'm going to remove everything related to the SQS part. So you can prepare resource creation. I'm going to delete this. I'm going to get rid of everything related to SQS. So there's not going to be an approved resource for any operation, okay? And the very last one should be deletion. Yep. We're going to get rid of all references to SQS. Okay. So this is going to be my PR. Remove SQS for operations. Let's push this. This is a brand new branch. So let's do it this way.
And this will now create a branch on the Git repository, and we're going to now go to GitHub and merge that PR, and that will then trigger a redeployment.
Yes.
And after the redeployment, we would then not be able to create an SQS queue again, right?
Yes, exactly. So there's a new branch, as you can see. What I'm going to do is create a pull request, which should trigger the GitHub action. So you can see my change. Okay, let's create the pull request. Oh, you can see that it's triggered. And everything that we showed in the workflow is going to be triggered. You can put extra tests or remove the tests. It's just based on, you can adapt this whole thing for your organization. And at the very end, after the security scans are done, we're going to be planning this. And once we merge the code, it's just triggered the same pattern, but this time it's not going to be planning, it's going to be applying the Terraform code. So not to lose any time, we can leave it here, and I will be doing the apply from my terminal, and so that you can also see what is actually changing in leave time. Okay, second.
So the Terraform apply will now change the AWS infrastructure, and especially the policies of that we have just talked about, right?
Exactly.
And with that, we are going to then see that managing SQS queues through the CLI is not going to be possible anymore.
Exactly. So let's go to the Terraform section and do a Terraform plan, okay? And even before doing that, what we can do is just to show you that if you'll go here to the application and change anything, you just extend this comment and do the same thing like the Terraform plan. It's going to be a whole new scenario here, because now what we did, we touched the application, right? If you're touching the application by using its hash, either script or the application code base has changed, Terraform will know that, okay, I need to build a new version by using this script. And once I put it into this place, the S3 object should come and grab it and put it into S3 bucket. And then we have to grab that hash and put to the code version. And that will trigger the AgentCore runtime to know, oh, we have a new version then. Then let's create a new runtime version. So this is the whole thing works, under the hood.
Okay.
And so let's do Terraform apply after approve at this point, just to make things faster. And we don't have to redeploy the application overall. So that we do the change and just test the CEDAR policy in action. Okay. So this thing happens when you use Terraform in multiple places, right?
True.
So it just happened that my local computer was faster. It was locked. So the CI failed. Like, it's locked because you're running on somewhere else.
Yeah, of course,
exactly,
because you're running locally. Yeah.
Exactly. Okay. So everything is applied. As you can see, I have elaborate outputs here, giving me all the outputs that I need at this point. And one resource was destroyed and added back, which is all about the policy part. So what it did, we used AWS CLI to find the policies that exist. We deleted them. We created the new version of them where we don't have SQS. Now I'm going to go back and do the exact thing that I did. And this time, agent will be like, something is wrong because I'm not able to create it.
Yeah, because there is no permissions for it.
Yeah, exactly. And it's startled usually that if I have the IAM permissions, something is wrong because I cannot create. Maybe I can give you some AWS CLI command or CloudFormation template that you can apply yourself. Like, this is the coming from the system prompt usually. Okay, create me another SQS queue called demo2 in view central one. Let's kick this off. Okay. Oh, it seems tool execution was denied by a policy. See?
Oh, really? So that's what we expected. Yeah.
Yeah, exactly. This is the expected output, right? And I can retry whatever. Or this is coming from the system prompt part of the things, but usually you just saw how we easily change something and automatically applied everything by using the whole Monorepo thing. So I really invite you folks, just this is going to be in the description, and I'm also open to any questions. If you have anything, you can come my way. I believe we could share some comments on it. Just to go and play with it or use. So what I'm also planning to do, I'm gonna building up some code sub agent based on this Monorepo thing publicly, so you can potentially make use of that skill and combination of skills and agents, cloud agent, just to build the skeleton of this application, of this toolset literally, and see yourself how it works for you, and use it as a baseline. Hopefully.
Cool. Sounds like a lot of learnings here. At least for me, there was a lot of learnings already. Tarlan, let's stop your screen share so we can kind of do a wrap up and
sure.
Then conclude the session for today. So, Tarlan, what do you think is the most remarkable thing that people need to take away out of the session today?
Any technical session from any, let's say, any struggle, the takeaway is that one step at a time. Consistency is the key. Even if, it doesn't matter. It applies to everything. If you're a technical person especially, don't be afraid. Take a step. You will be much more closer to your goal if you do the step. So it's been working for me all the time. Never be afraid. Take the step. Try new things. Don't be limited to any best practices things. Like people go, it's not a best practice, you shouldn't be doing it this way. It's literally a limitation. Experiment and find a new way, find a better way, and deliver it to the world. Because you're a technical person, this is what you are expected to do. Make the world better in any means, and especially in technical means as an engineer. So just take the step and try things.
Thank you very much. And I'm taking away that it's way easier to build agents with AgentCore than building them without AgentCore or something like that. Obviously, other cloud providers have similar platforms that you can use over there as well. We have been looking at AWS over here, but I think it's still a very valuable session. Tarlan, how can people ask you for more questions after they have watched this video? Can they reach out to you on LinkedIn, or what's your preferred contact mechanism?
I think LinkedIn is the best way. Yeah, we can share the link to profile, and I'll be looking forward for any
his link in the description below, right? So thank you everybody for watching, and I hope to see you in the next video that I'm creating. And Tarlan, thank you very much. See you soon.
It was an honor.
Let's meet in person soon.
Yeah, hopefully.